So, good morning, students. This would be the next lecture for rotational mechanics from the irodov series. Okay. So, this series is basically structured towards those that are preparing for JEE Advanced. So, in this specific lecture, I have covered from question number 276 to 272 that lies in the chapter of rotational motion. Okay. So, there are concepts of toppling, there are concepts of centrifugal force, and a concept of rolling motion. Okay. So, just follow through the lecture, and if you have any doubts, mention in the comment section. Okay. So in this question, this is the ball, okay, or this is a sphere, and this is rotating in this circular orbit, or this is rolling in a pure motion in this circular orbit. The question is asking what is the total kinetic energy of this sphere. So you already know the total kinetic energy of any moving body about an origin is nothing but kinetic energy about x-axis plus kinetic energy about y-axis plus kinetic energy about z-axis. For rolling, if the body is considering both rolling and translation motion, then this kinetic energy would be translated into two components. That means kinetic energy of rotational is nothing but kinetic energy of x component plus kinetic energy of y component plus kinetic energy of z component plus kinetic energy of translation, or kinetic energy of x component plus kinetic energy of y component plus kinetic energy of z component. Okay, and out here this is nothing but half I omega x square, half I omega y square, half I omega z square, and this is nothing but half m vx square plus half m vy square plus half m vz square. This much is clear. Okay. Now my primary question is, what is the angular velocity to this axis of rotation? See, if this is rolling about this surface in a pure rolling motion, then I can say that v, or velocity means velocity in this direction, or velocity in this orbit, is equals to omega into r, where r is nothing but radius of the sphere. Okay, so v is equals to omega, or omega is equals to v by r, v by small r, where r is nothing but the radius of the sphere. Okay, one more question. What is the angular velocity about this axis? Okay, angular velocity about this axis is nothing but, see, this sphere is moving in a circular orbit, isn't it? This circular orbit. Okay, and see, if it is moving with v, with pure rolling motion, can I say in this orbit v is equals to omega into r? Okay, so this omega is nothing but v by capital R. Okay, so I got two axes, x axis, y axis, and is there any z axis? I don't think there is any z axis. Okay, and one more thing, there is a translational kinetic energy out here. Okay, the translational kinetic energy is nothing but the velocity of the object itself. Okay, so let us solve the problem. Okay, omega x, or kinetic energy in x direction, is nothing but half. What is the moment of inertia over this axis of rotation? Is nothing but I y. I is nothing but 2 by 5 m r square. Okay, or m small r square into omega x. What is the value of omega x? V by r whole square. Okay, plus kinetic energy along y-axis. Kinetic energy along y-axis is nothing but half moment of inertia through this axis, or moment of inertia through this axis of rotation. Okay, so half into what is the moment of inertia through this axis of rotation? Is nothing but 2 by 5 m square. So if I apply parallel axis theorem between this axis and this axis, I'll get moment of inertia is nothing but 2 by 5 m r square plus m into capital R square. Okay, so this is half omega y square into v by capital R whole square. Okay, and there is no angular velocity over z axis, so this is not applicable. Okay, and since we have already taken rotational velocity, this rolling motion out here, okay, or this rolling motion out here is taken care of by this parameter. Okay, by this parameter. So we do not need to write an additional half in v square out here. Understood? So this entire thing will be not applicable out here. So total kinetic energy is nothing but this much. Now if I just simplify this one, okay, how do I simplify this one? Okay, so let me just say v by r whole square is nothing but v square by r square, v square by r square. Let me cancel this r square and r square. Okay, and what else can I cancel? Okay, this one. Okay, this v by r whole square can be written as v square by capital R square, v square by capital R square, and let's divide this r square inside. Okay, so this will be m, this will be r square, small r square divided by capital R square. Okay, so what I'm doing is I'm dividing this by r square, r square. Okay, so this will stay as it is, this r square and this r square will get cancelled. Understood? Now let me take common v square out here. Okay. This v square and this v square I'll take common. So v square, let me cancel out these two and these two get cancelled. So it become 1 by 5. Okay. So v square into 1 by 5 m plus half into 2 by 5. Achha. Half into 2 by 5 m small r square divided by capital R square plus half m. Achha. Understood? Is equals to total kinetic energy. Now this 1 by 2m plus 1 by 5m. What is 1 by 5 plus 1 by 2? It is nothing but 7 by 10. Okay, if you take LCM, this thing will turn out to be as 7 by 10. This 1 by 5 and this 1 by 2m will turn out to be as how much? 5 in plus 2, 7 by 10. Okay, 7 by 10m plus half into 2 by 5 m r square by capital R square. Okay, is equals to total kinetic energy. So this is our answer. Just let's simplify a little bit. This half and this half will get cancelled, so it will be 1 by 5. Okay, so this is our final answer. Now this question is unintuitive in nature. To understand this question, just imagine yourself to a pole dancer. Okay, so this is a pole and you're dancing on it. Suppose you're revolving on it. That means this is your eye. Okay, and this observer is moving with angular velocity omega around this pole. Okay, or you can also imagine this as suppose you're standing and you're just floating about yourself. Okay, like Shaktiman or something. Okay, the question is asking if I keep an object out here on the ground. Okay, this object is stationary with respect to someone on the ground. Okay, so if I keep a static object out here with respect to you yourself, okay, this object will experience a centrifugal force of this magnitude, okay, and a Coriolis force of this magnitude. You have to demonstrate these two. Understood? So suppose you are rotating. What is the centrifugal force on this object? The centrifugal force on this object is nothing but m omega square r. Centrifugal force, F centrifugal. We have already demonstrated this, or this is the formula for centrifugal force, m omega square r, where r is the distance between center of mass of this body and the axis, and this r is perpendicular distance from this axis and center of mass of the body. Okay, so if you see this one, okay, so with respect to yourself when you are rotating, the centrifugal force that would be acting on this body is nothing but m omega square r. Understood? And now see, if this body is kept static on the ground and you are rotating around this pole, according to you, this body, okay, will revolve in this circular orbit opposite to the direction of your rotation. Just keep a pen above your eyes or in front of your head and just rotate your head. According to you, if you rotate your head in clockwise direction, according to you, the pen will rotate in anti-clockwise direction, or the pen starts to revolve in anti-clockwise direction. Same thing is happening out here. So when you are rotating in this direction, the block out here will try to revolve in this direction. Okay, the velocity of the block out here is in this direction, velocity, and v is nothing but exactly equals to omega into r, where r is the distance between axis and center of mass of the body. Okay, now what is the value of centrifugal force? Sorry, what is the value of Coriolis force? Coriolis force. Coriolis force was nothing but minus 2m v cross omega, or minus 2m, or 2m omega cross v. I'm just removing the minus part. Omega cross v. Okay, I'm a little bit wrong. It is v cross omega. Okay, not omega cross v. If I remove the minus, it will be nothing but v cross omega. Okay, now if you see, this velocity is nothing but velocity as seen by observer. So what is the velocity as seen by this observer? It is nothing but omega r, isn't it? So this v is nothing but omega r. This is nothing but the angular velocity of the observer. Okay, and what is the angle between omega r and omega? It is nothing but 90 degree. Okay, so our Coriolis force is nothing but 2m omega square r. Understood this much? Okay, or this one. Okay, this is given in the question. This formula itself is given in the question. I just broke this formula into further this value. Okay, for this specific question. Okay. Okay. Now we'll see. Okay, see what actually is happening out here. According to your eyes, okay, this mass m that was kept out here will start to rotate in this direction. Okay, this object or this static object that is kept on the ground will revolve in this circular orbit. Why? Because you yourself are rotating around this pole. You yourself are rotating around this pole in opposite angular direction. Okay. So this out here is nothing but R. Okay. And there are two pseudo forces. One is centrifugal force. One is centrifugal force in this direction, m omega square r, and one is the Coriolis force in this direction, 2m omega square r. The net force is nothing but in this direction or towards this direction, which is nothing but m omega square r. Now, if you observe properly, okay, this Coriolis force or this net force, that means Coriolis force minus centrifugal force, is nothing but the net force that is acting in inside direction. So, according to you, the centripetal force will be nothing but this one, and m omega square r, the centripetal force, is equals to mass into acceleration omega square r. So understood how the net Coriolis force in this direction is actually the centripetal force that is keeping this m rotating in this orbit in clockwise direction. Okay. So this is question number 1.268, and this question you have already done in circular motion in the previous chapter. Okay. So in this question, okay, this is the axis of rotation. Okay, and around this axis, this stick is rotating with angular velocity omega. That means this stick is rotating like this. Okay, angular velocity omega. The question is asking what is the torque generated in this rod, okay, due to centrifugal acceleration. So if you fix your frame of reference out here, okay, you fix your frame of reference to this stick out here, each particle or each elemental mass out here, dm, will experience a centrifugal force, which is nothing but m omega square r. Okay, and this centrifugal force will try to rotate this rod in clockwise direction, isn't it? So we have to find out the total torque generated due to this entire length of rod. So let's, okay. So if this is our origin, okay, let's say this is our origin. What is the torque generated due to this m omega square r or elemental mass? This elemental mass dm omega square r. Okay. So let's take this first thing. Centrifugal force. Centrifugal force is nothing but elemental mass into omega square r. What is the value of r? The value of r is nothing but distance from the axis. What is nothing but this much distance, isn't it? So if this distance is x, suppose I take this distance to be x. Okay. This distance is x. The value of r is nothing but x cos theta. The value of r will become x sin theta. Okay, not cos theta, x sin theta. Understood this much? And what is the torque generated due to this force? Torque is nothing but r cross f. Okay, or r cross f. What is the value of r cross f? This torque, this force will try to rotate this rod in this direction or in this direction, isn't it? So torque is nothing but centrifugal force into r sin theta, and r sin theta is nothing but x cos theta. Okay? That means this much distance is nothing but r sin theta. Okay, so torque is nothing but magnitude of r into magnitude of f into sin theta. Now if I just take this force out here and make it out here, and if I take this sin theta out here and take it out here, okay, f is taken out here. This entire sin theta or r sin theta is nothing but this much distance. Okay, and f is nothing but this one. So r sin theta is effectively nothing but x or x cos theta. That means this much distance. Okay, or x cos theta. Understood? So if I write elemental torque due to elemental mass is nothing but x cos theta into what is the value of force? dm omega square r or x sin theta. So the net torque is nothing but from 0 to L by 2. If the length of the rod is L, okay, what is half of this length? L by 2. This much length is nothing but L by 2. So 0 to L by 2 into 2. Why did I do into 2? Because torque is generated in this length, but torque is also generated in this length. No? So this length will also experience centrifugal force, and that torque will also rotate in upward direction, isn't it? So net torque from 0 to tau is equals to, let's take all the common term outside. Okay, cos theta sin theta into omega square and into 2. Okay, what is inside the bracket? Inside the bracket is nothing but x square into d. Okay, now how do I convert this elemental mass in terms of x? Let's check. The entire rod is homogeneous. That means the linear density of the rod is same everywhere, isn't it? So if I say linear density of the rod is nothing but mass of the rod divided by length of the rod, it is nothing but elemental mass of the unit divided by elemental length of the unit. This much length is nothing but dx. Now this small length of element has length dx. Okay, so from this equation I can get that dm is equals to m by l into dx. Now if I just substitute that, entire torque from 0 to tau is equals to 2 cos theta sin theta omega square into x square m by l dx. Okay, from 0 to l into 2. Achha, into 2 is already done. Now let me take this constant term also outside. Okay, so this dx would be cleared with this one, and this thing would be separated. This m by l would be taken out there. Okay, now see, what is the integration of x dx? It is nothing but x cube by 3, x cube by 3, and this is nothing but not l but l by 2. Okay, 0 to l by 2, because if the entire length of the rod is l, the length of half of the rod is l by 2. So let's solve this one. X cube by 3 from 0 to l by 2 is nothing but l cube by 8 into 3. Okay, l cube by 8 into 3, or l cube by 24, or l cube by 24. Okay, now if I substitute this entire thing out here, what do I get? Or entire torque is how much? Let's just substitute this out here. Or entire torque is nothing but 2 cos theta sin theta omega square m by l into l cube by 24. L cube by 24. 2 and this will get cancelled to become l. L and L will become cancelled to become L square. So let me write this neatly. L got cancelled 24. Instead of 24, I have to write 12 out here. 12 out here. And instead of this L cube, it becomes L square. Okay, this 2 got cancelled. Okay. So this is our answer. The torque due to this centrifugal force is nothing but this value, and this is our answer. Okay. Now in this question, there is a conical pendulum. Okay, and instead of a fixed point mass, there is a rod of length L and mass M. This rod that is rotating in this direction. This rod is rotating in this circular path. Okay, in this circular path. This is the mass of the rod is M and the length of rod is M. The question is asking at what angle will this rod stay. Okay, now see, to find out that, we have to focus on one thing. See, if you take elemental mass, okay, dm, at distance x from the origin, our origin is out here. Okay, then this elemental mass will provide a centrifugal force in this direction, isn't it? Force due to centrifugal, and there is a force due to gravity. Gravity force is in downward direction. Now, if I say about this point, if the torque due to centrifugal force, okay, the torque due to centrifugal force will try to rotate this rod in upward direction, and the torque due to gravity force will try to rotate this rod in downward direction. So I can easily say that torque due to centrifugal force is equals to torque due to gravity force. And if I balance out this two torque, I'll get the value of angle theta. So let's check what is m omega square r. Centrifugal force is dm omega square r, but the value of r is nothing but distance from the axis, which is nothing but x sine theta. X sine theta. And the value of torque is nothing but r cross f, no? So r cross f is nothing but r sine theta into f, or rf into sine theta. So r sine theta is nothing but, see, if this is the direction of centrifugal force, the value of r sine theta would be nothing but this much, or this much. Okay, so the value of r sine theta is nothing but or r cross this much, or magnitude of r into dm omega square r. The value of r is nothing but x sine theta into sine theta or sine phi. Okay, the value of r sine phi, if I take this dm out here and take this r sine phi out here, okay, the value of this r sine phi is nothing but x cos, acha, x cos theta. Understood this much? Similarly, for gravity force is nothing but r cross mg, but gravity force is in this direction. So r sine theta into mg, the value of r sine phi would be nothing but this much length, isn't it? And this much length is nothing but L by 2. See, gravity force always acts from center of mass, and the center of mass is at L by 2. And L by 2 into sine theta is nothing but this much distance. So it is nothing but r into magnitude of r into sine theta, sine phi, or whatever this angle is, into mg. But these angles are the angle between this vector and this vector. Okay, this angle is nothing but angle between this vector and this vector. Okay, So the value of r sine phi out here is nothing but L by 2, how much? Sine theta. And if I balance out this one, x cos theta into dm omega square x sine theta is equals to L by 2 sine theta into mg. Now what I'll get is, I can cancel out this sine theta and this sine theta from the left hand side. Okay, what else can I do? See, if the entire mass of the rod is L and the entire rod of length of the rod is L, then linear mass density is equals to m by L is equals to dm by dx. From here, I can easily say that dm is equals to m by L into dx. So if I substitute that one, I'll get x cos theta into m by L into dx into omega square x is equals to L by 2 mg. Okay. Now if I compile this x and this x together, I'll get nothing but x square. Okay. And let's take all the constant term outside. Constant term. This one is constant term. M by L constant term. Okay. Omega square. Omega square, I have to find out the value of omega square. Okay. The angular velocity omega is given. Okay. And x square. Let's take this x square out here and dx out here, which is equals to that is equals to L by 2 mg. Okay. Now if I integrate this x square dx from 0 to L, I'll get my answer. I'll get the value of theta. Okay. So let's solve this problem. Let's take this entire equation a little bit up. Okay. So m by L omega square into cos theta into x cube by 3 from 0 to L is equals to L by 2 mg. Okay. Now if I integrate this one, I'll get something in the manner of something like this. M by L omega square cos theta L cube by 3 is equals to L by 2 mg. See, L and this would become L square, and this L and this square would become L. Okay. So this is our primary cancellation. Okay. What more things can I cancel? This M is nothing but capital M. This M and this M will also get cancelled. Okay. So I'll get cos theta. So my answer would be nothing but cos theta is equals to, the remaining term would get transferred to the right hand side, 3g by 2 L and omega square. 3g by 2L omega square. 2L omega square. This is my answer. Understood? Now to understand this question, you need to understand the concept of topic. Okay. Suppose any body is moving over this surface. Let this not be a circular body, let this be a square body. So if this was moving with velocity v, after overcoming an obstacle, or suppose there was an obstacle kept out here. So after overcoming an obstacle, or when this body collides with the obstacle, this body will tend to topple. Okay. So what is the condition for toppling, or why does the body do this? See, toppling only occurs when the net torque passing through the axis through center of mass is non-zero. So when net torque about an axis passing through center of mass is non-zero, toppling takes place. Okay. Now let's just understand the dynamic of top. Okay. So let me just draw this diagram a little bit below, and let me draw an intermediate between this diagram and the first diagram. Okay. This is intermediate diagram. That means the body is just starting to lift. Okay. The body is just starting to lift. Okay. This angle out here is very negligible. Okay. So if this is A, okay, this is B. And in our question, in this specific question that is given out here, A is equals to B. That means this is a keyword. Okay. See, if I draw the free body diagram, mg acts in downward direction, friction force acts in this direction, and in normal cases, see, friction force will act in this direction, mg force will act in downward direction, and normal reaction force will pass through out here. But in case of toppling, normal reaction force can only pass through the point where there is contact. If there is no contact, suppose there is no contact in this portion, so how will there be any normal reaction force out here? So if out here the block is starting to touch the body, okay, out here there is a point of contact. Okay, so normal reaction force will pass through the first point that comes in contact. This is normal reaction force. That means as the body is rotating in this direction, the normal reaction force will shift from this position to this position. Understood? So as the body is trying to rotate, the normal reaction force was initially out here. As the body tries to stop, the normal reaction force will shift towards right. Understood? So now let's write down the net torque through center of mass. Okay. So in this question, I will write down net torque acting about axis passing through center of mass. About center of mass. So out here, I'll take clockwise torque as positive and anti-clockwise torque as negative. Okay. Torque, angular momentum, these are all axial vectors. Okay. So the torque due to friction force is trying to rotate the body, and this torque due to normal reaction force is trying to balance that toppling torque. Okay. So net torque is nothing but friction force. Torque due to friction force is nothing but Fr into this much distance, isn't it? And this much distance is nothing but V by 2. Okay. Minus torque due to anti-clockwise, N into, let this distance be x. X naught. Okay. X naught. Understood? Is equals to torque or net torque, total torque, I into L. And if this value is non-zero, if this is non-zero, that means the body will try to topple. Okay. So at just the start of toppling, at just the initiation of toppling, okay, the toppling is just starting to occur. Okay. That means this value is nearly equals to zero, isn't it? This value is nearly equals to zero at the starting of toppling. Okay. So Fr V by 2 minus N into x naught is nearly equals to 0 at the starting of toppling. The toppling is just about to start. The net torque, just wait a minute. The net torque is just enough to initiate toppling. Is just enough to initiate toppling. Okay. So if I send this to the right hand side, Fr into V by 2, this is nothing but 2. Fr into V by 2 is equals to N into x naught. And from vertical component of forces, if I draw the vertical forces, N is equals to mg. And Fr is nothing but maximum value of friction force is nothing but mu mg. So out here, friction force or maximum value of friction force is nothing but mu mg, and N is nothing but mg. So from this equation, I'll get x naught is equals to mu d by 2. Okay. Now, what our actual question? The actual question, what out here said is that explain this entire scenario of coupling, okay, from origin. This question, what basically this question says is that we have to explain this entire toppling, but from the axis that is passing through origin. That means what is happening out here? This is origin out here. Okay, origin. This is the body out here, and out here toppling is taking place. Okay, so N is just shifted by some x naught distance from the center of mass, isn't it? Okay, and this is A, and in our question, the value of B is also equals to value of A because this is a Q burst. Okay, so net torque is nothing but out here. This is mg. Now, if I take this as the origin, okay, this as the origin, then this distance from origin to the start of the block is taken as x. So net torque is torque due to mg plus torque due to friction plus torque due to normal reaction force. Okay, I'll take clockwise torque as positive and anti-clockwise torque as negative. See, if I take this as the axis of rotation, this as the axis of rotation, net torque due to mg would be nothing but mg into x plus a by 2. X plus a by 2. Torque due to friction force will be equals to 0. Why? Because see, friction force acts along this line and r vector is also along this line. So the angle between friction force and r vector is nothing but 180. So torque due to mg means friction force is equals to 0. Torque due to normal reaction force is nothing but the value of normal reaction force mg, and mg shifted, the normal reaction force is shifted by this distance, no? So this distance or total this distance is nothing but x plus a by 2 plus x. Okay. So mg into x plus a by 2 plus x naught. This distance is x naught. Understood? Okay. And see, mg force is trying to rotate this body in clockwise direction. Normal reaction force will try to rotate this body in anti-clockwise direction. So this out here would be minus. Okay. So net torque is equals to mg x plus a by 2 minus mg x plus a by 2 plus x naught. Okay. Now, if I solve this question, so net torque that is passing through center of mass is equals to nothing but net torque is nothing but if I cancel out everything, mg into x naught by mg into x naught. The value of x naught as given in the previous question is nothing but mu naught mu into b by 2, and in this question b is equals to a, so mu into a by 2. The value of x naught would be nothing but mu into a by 2. Okay, so the net torque out here is nothing but mg into mu a by 2. This is the value of net torque. So this is the end of our question. Okay. In this question, okay, there is a rod AB out here. Okay, the mass of the rod is capital M and the length of the rod is L. And this rod is rotating about this axis with angular velocity omega naught. Okay. Now see the twist in the question. Okay. In this rod, there is a sleeve out here. Sleeve means ring. The mass of the ring is F. Now see, as this rod rotates about this axis, what will happen to this ring? This ring will try to slide outward, isn't it? This ring out here will try to slide outward. Okay. Now after sliding outward, there will come a time when the ring has entirely gone outward. Okay. So this is the rod. I'm showing you the moment when the ring has left the rod. Okay. Ring of mass small m has left the rod with velocity v. Okay. I have to find out this velocity v. Okay. My first question is, with whom is this respect means this velocity v is with respect to whom? Okay. Let's read the question. Find the velocity v dash of the sleeve relative to the rod at the moment it reaches this other end b. That means we have to take our frame of reference or rotating frame of reference, this frame of reference. Okay. We have to take this frame of reference of the rod. That means the ring moves from this position to this position due to centrifugal force. See, out here, what are the forces acting on this ring? The forces that are acting on this ring is nothing but normal contact forces. Work done by normal contact force is equal to 0. Gravity forces, work done by gravity force is also 0. There is no friction force. So the only force that is doing any kind of work out here is nothing but centrifugal force. And what is the work done by centrifugal force in this case? Work done by centrifugal force is nothing but force into displacement, or m omega square r centrifugal force. M omega square r into dr. Now some of you might get confused. The centrifugal force is a pseudo force, it cannot do any work. No one in the world says pseudo force cannot do any kind of work. Work itself is dependent upon frame of reference. So is kinetic energy. Okay. So work done, kinetic energy, these are all parameters that are dependent upon the frame of reference. Do not get confused out there. Okay. But my second confusion is, why do I need to integrate? I can just write force into displacement. See, as this ring moves towards this edge of the rod, what is happening? See, the centrifugal force out here is nothing but m omega square r. This much r. This much r is very little. So centrifugal force is out here also very little. So as the ring moves towards right, the centrifugal force out here would be m omega square this much r. So out here centrifugal force increased. Okay. So as I'm going from left to right, my centrifugal force is increasing. Okay. So the force is variable out here. That is why I'm doing integration out here. Understood? From 0 to L. That means from this position to this position. Okay. So work done by centrifugal force is nothing but work done by centrifugal force is nothing but m omega square r into dr. M omega square. My second question is the value of omega constant? Omega not constant? No. Okay. So as the thing is varying, or as the thing is going out, okay, as the ring is moving towards right, okay, the value of omega of the entire system will decrease. Why is that? See, as I'm just imagine for a moment, I'm applying conservation of momentum for this entire system. Okay. So this ring plus this rod is a system. Okay. Is there any external torque acting on the system? No, obviously not. But as the ring moves from left to right, see, as this ring moves from left to right, is the moment of inertia of the system increasing? Obviously, yes. Moment of inertia of the system about this axis of rotation? Obviously, yes. Isn't it? So my question is, the moment of inertia is increasing. So the angular velocity out here. So as the rod moves towards right, the angular velocity of the system would decrease. Okay. So at certain instant when the angular velocity is omega, the work done by centrifugal force was m omega square r dr from 0 to L. Okay. So we get nothing but m omega square r square by 2, which translates from 0 to L. Or our centrifugal force is nothing but m omega square L square by 2. Okay. Now see. Now what further equations can I apply out here? Can I apply work energy theorem between these 2 points? Okay. Let's apply work energy theorem. Applying work energy theorem. What is work energy theorem? Change in kinetic energy. So final kinetic energy is nothing but half m into omega square plus m, small m. The mass of this ring is small m. Okay. half m, not m, let's say this I, final moment of inertia, omega square. Okay, half I omega square plus half m v square. Understood this much? Okay, this is final kinetic energy minus initial kinetic energy. What is initial kinetic energy? Half I omega naught square. Okay, this is initial kinetic energy. Understood? Is equals to work done by centrifugal force. This is nothing but m omega square L square by 2. Understood this much? See, there is no other forces apart from centrifugal force doing any kind of work. Understood? The value of I out here is nothing but ml square by 3, or moment of inertia of the rod or the axis, ml square by 3. So let me rewrite this equation a little bit. Okay, half I ml square by 3 into omega square plus half mv square, this is nothing but the final kinetic energy, minus half ml square by 3 omega naught square, okay, is equals to m omega square L square by 2. Understood this much? Okay, now this is fair and fine. My next step is, how do I solve for this v? I have to solve for this v, no? So using only one equation, see the problem I'm arising out here. Okay, the capital M and small m are given in the question. The variables that I introduced out here are nothing but this omega, this omega. So I somehow need to dissipate this omega. Okay, so I need to find a relation between omega naught and omega. And how do I do that? Applying conservation of momentum. See, in this entire system, no external force is applying. No external torque is applying on the system. No, is being applied on the system. So you can apply conservation of momentum. So applying conservation of momentum, applying conservation of momentum. What can you say? Okay, so let's apply conservation of momentum. So how do I apply conservation of momentum? Initial angular momentum is equals to final angular momentum. So initial angular momentum was nothing but half, not half. Why is the initial angular momentum half? Okay, initial angular momentum is nothing but I omega 1. So m L square by 3, m L square by 3 plus small m into 0 square, because the ring of mass m is situated at the axis omega naught into omega naught is equals to final angular momentum, which is nothing but ml square by 3, which is the moment of inertia of the rod, plus m into L square, because now the sleeve is presented at the outer edge. Okay, into omega. Okay, now if I plug in the value of omega in this equation, I'll get my answer. Okay, so let me just simplify it. Okay, let me simplify this term also. Okay, I'll simplify this term also. Okay, from numerator and denominator, what I'm doing is I'm taking ml square by 3 common from numerator and denominator. Okay, so I'll get nothing but ml square by 3 into 1 divided by ml square by 3 into 1 plus ml square divided by ml square by 3, ml square divided by ml square, and 3 would go up. So this L square, okay, this L square and this L square would get cancelled out. Okay, so I'd get 1 plus 3m by m. This 3 would come out here. Let me just write this m. Okay, why this 3 running around? This 3m by m would come out here. Okay, and this entire thing would get cancelled. Okay, ms square by 3 and ms square by 3 is getting cancelled. So it will be nothing but 1 plus or omega naught by this term is equals to omega. Okay, so m minus 3m. Okay, we have to substitute. There is no way we can do it any other further. Okay, this omega will be substituted out here. And now when I solve for this equation, I'll get, if I substitute the value of omega out here, I'll get v is equals to omega naught L under root of 1 plus 3m by capital M. Okay, so this would be our answer.